Okay, so here is a tricky question. Part A is not so tricky. Part B very tricky. Okay, what we're being asked to do is find the fourth roots of -4 in Cartesian form. Okay, so we're trying to basically solve the equation z to the power of 4 is equal to -4. So I'm not going to bother with any sort of factorization method here. I'm going to use the nth roots method. Okay, so let's turn -4 into polar form. Okay, so hopefully you can see that, it's something like that. So it's going to have a modulus of 4 and an argument of pi, 180 degrees. Okay, so we can rewrite z to the power of 4 as 4 cosine of, well, notice that actually it's pi, but it's also plus 2k pi, okay? Because remember, we can go around any multiples of 2 pi and we end up back at the same place. So factoring that out becomes 2k plus 1 pi. Okay, so 2k plus 1 pi plus I sine 2k plus 1 pi. Okay, and now raise left-hand side and right side to the power of a quarter. We are going to get z. Apply demoivre's theorem, we need to raise 4 to the power of a quarter and times the argument by a quarter. So we're going to get cosine of 2k plus 1 of pi over 4 plus I sine of 2k plus 1 times pi over 4. So all I've done there is just apply demoivre's theorem. Okay, so what is 4 to the power of a quarter? Way of writing that, I could rewrite it as 4 to the power of a quarter is equal to 2 squared to the power of a quarter, which is 2 to the half, which is root 2. So that's going to be root 2 cosine of 2k plus 1 pi over 4 plus I sine of 2k plus 1 times pi over 4. Okay, right, now we can use that to basically find my 4 solutions to this equation. What we're first of all going to do is we're going to sub in where k is equal to 0. Well, if k is equal to 0, we're going to get z equals root 2 times cosine of pi over 4 plus I sine of pi over 4. So that's going to become root 2 times 1 over root 2 plus 1 over root 2i. Root 2's will cancel away. I'm going to get 1 plus I. Okay, so I'm just going to make a note of that. Z1 is equal to 1 plus I. Let's delete that now. Okay, and let's go for the case where z is equal to 1. If z is equal to 1, we're going to get root 2 times cosine of 3 pi over 4. Hopefully you spot the pattern of what's happening. Okay, which is going to be root 2. I won't bother to draw the graphs. You should be able to work out that cosine of 3 pi over 4 is negative 1 over root 2. And sine of 3 pi over 4 is positive 1 over root 2. 1 over root 2i. And so again, we're going to end up with minus 1 plus I. Minus 1 plus I. Okay, let's look for Z3, which is the case where k is equal to 2. Okay, so if k is equal to 2, we're going to end up with root 2 times cosine of 5 pi over 4 plus I sine of 5 pi over 4. That's going to be root 2 times negative 1 over root 2 minus 1 over root 2i, which is going to be minus 1 minus I. Okay, and finally, let's sub in the case where k is equal to 3. We're going to get root 2 times cosine of 7 pi over 4 plus I sine of 7 pi over 4. That's going to give me a positive for 7 pi over 4, so I'm going to get root 2 times positive 1 over root 2 and a minus for the sine I. Okay, so that's going to be equal to 1 minus I. Z4 equals 1 minus I. So there are my 4 roots to this equation. Okay, my 4 roots of this equation, and they're all complex. So all 4 of them are complex roots. Now, so part B, so that answers part A. Part B says, hence write z to the power of 4 plus 4 as a product of real quadratic roots. So we're just rearranging this, we're just rearranging this to z to the power of 4 plus 4 equals 0. So what's it actually asking me? It says, write z to the power of 4 plus 4 as a product of real quadratic factors. Well, so what does that mean? It means it wants you to write it as quadratic factors like this. We'll say that's dz squared plus ex plus f. So we basically want to factorize z to the power of 4 plus 4. And I can do this using my roots, okay? The way we do this is we use the sums and products of roots. It's something we learned a long time ago. You probably need to revise sums and products of roots. But essentially, we know that... well, actually, let's just start from the beginning. What I'm going to do is I'm going to pair off my solutions, okay? I'm just going to look here at 1 plus I and 1 minus I. Now I'm going to look at the sums of those solutions. Well, that's going to give me 2. And I'm going to look at the product of those solutions. That's going to be 1. Sorry, that's going to be minus I. So the i's will disappear, and we're going to get minus I squared. I squared is negative 1, so that's going to be 2 as well. So the sum of the product is 2, and the sum of the roots is 2, and the product of the roots are 2. Now, let's just take a general quadratic with roots alpha and beta. Alpha and beta, okay? That means my quadratic can be written like this. And in the case of this, I probably need some number here, but I know that's going to be 1 because the coefficient of z to the power of 4 is 1. So I don't need that a. Okay? Now remember, if we expand that, we're going to get x squared minus alpha plus beta x plus alpha beta. So we can see that this number, or rather the negative of it, is going to be the sum of the roots, and this number here is going to be the product of the roots. So the sum of the roots is 2, and the product of the roots is 2. So this must have come from the following quadratic: x squared minus 2x Okay, it's always going to be the negative of the sum, for a quadratic that is, plus 2, the product of the roots. Okay, so that is going to be one of my quadratic factors. So it's going to become z squared minus 2x plus 2 multiplied by a different quadratic. Well, let's use the other pair. Let's use the other pair, which is minus 1 plus I plus minus 1 minus I. That's going to be equal to negative 2. Let's look at the product of those roots. Minus 1 minus I is going to give me equal to 1 minus I squared again. It's going to be equal to positive 2. So it's going to be exactly the same, except this is going to be a negative. Negative, so it's going to become positive. So it must have come from the quadratic z squared. Sorry, that should be z. Plus 2z plus 2. Okay, so we're getting z squared plus 2z plus 2. And there is my solution. I've factored z to the power of 4 plus 4 in terms of two real quadratic factors. That's one of them. That is the other. Okay? If you didn't fully understand that, it's because you don't fully understand the sums and products of roots. I wouldn't blame you. It's been a long time since we've spoken about them. But that probably one for your revision. One of the first things you might want to do as part of your revision, okay, is reminding yourself